To express the amount of biomass used in a material, various approaches are available, each with their own method to evaluate and slight differences in outcome. To be able to compare between articles, it's therefore important that they are evaluated using the same method. But before we dive into it, we need to take a step back and explain what biomass is. According to European guidelines, the term biobased means nothing more than derived from biomass. The term biomass focuses on materials of biological origin, apart from fossil materials and materials that are incorporated into geological formations. Biomass doesn't refer to the way materials are sourced or transported. When you talk about biomass, you need to say which method of calculation was used, and you need to be able to mention the measured or calculated percentage. The first method is a calculated approach called EN 16785-2. The second one is a measured method that is referred to as ASTM D6866. To get a clear understanding of the differences between these two methods, we're going to explain it by using a brand new pair of shoes. In this case, they are made from leather, but they could also be made from any other material. Let's start off with the most extensive calculating method, EN 16785-2. This method calculates the bio-based content in relation to the non-bio-based content of the dry material according to 4 key components: carbon, hydrogen, oxygen, and nitrogen. To calculate this correctly, we need to take into account every single component of the shoe, from the retanning agents to fat liquors, dyestuffs, and all other components. Data from the supplier is needed to indicate its origin and ensure an exact calculation. No assumptions or estimations here. But as a shoe can consist out of 4 to 10,000 parts, and every single part has to be calculated, you can imagine it's quite a challenge to get all the right data in. Suppliers and many clever chemists are therefore put to work in order to create a clear overview of all the specifics. All components combined give us the answer to the total amount of bio-based content in this shoe. But what if you don't want to calculate the bio-based content, but measure the bio-based carbon content instead? In that case, we use the ASTM D6866 method, which solely focuses on carbon, more specifically, organic carbon. To indicate the contents of the carbon, it's divided into biocarbon and fossil carbon. Well, that might sound difficult, so let's look back at the example with our shoe. ASTM D6866 is a result of the final product. To measure the bio-based carbon content, we have to throw the shoe into the shredder. All the small pieces of the shoe are put into a machine, and the material combusts for 4 hours at 900 degrees. After those 4 hours, the C12-C14 ratio comes out using accelerator mass spectrometry. This is a report that shows the ratio between bio-based and fossil carbon of the total organic carbon of a product, for example, a shoe. And that's how the two methods work, both with their own pros and cons. EN 16785-2 is a great and reliable method. Nevertheless, it requires time and effort, as it can be hard to gather all the information about every single component from different suppliers. In the end, you get a sum that shows the renewable bio-based content in relation to the dry weight of a product. ASTM D6866, on the other hand, is a method that is more progressive and efficient. Here, you only have to shred the entire product to measure the bio-based carbon content in relation to the total organic carbon content of a product. And that's how you either calculate or measure the bio-based content of a shoe or of any other product. Awesome, right? Would you like to learn more? Please contact us. We are always happy to talk about all things chemistry.